Welcome to Machine Learning Lesson 3.3. In this lesson, we're going to see how we can use a library called Seaborn to visualize data. One of the things you'll notice as we're doing this is that underneath Seaborn is actually Matplotlib. So let's get to it. So we have imported the Seaborn SNS. If you go to most tutorials, that's what you see as the alias for Seaborn. Let's go ahead and run this. And this is a data set we've worked with in past videos, such as cars data set. And let's jump right into it and let's do a scatter plot of some of these features. So let's do SNN, scatter plot. And one of the things you'll notice with Seaborn is the addition of a couple of extra parameters. So for instance, there's a parameter called data, which you specify where's this data coming from. So we're just going to use the whole data frame. Now by doing that, we can now specify the x-axis as simply the column name. So let's do a scatter plot of the year versus the mileage. Whereas in using Matplot, you would have had to do something like this, which you can also do here. But it's so much easier simply to specify that the y-axis would use the mileage feature. It's also more readable. Okay, so looking at the chart, it's a standard scatter plot, nothing special. We could have actually gotten the same thing doing Matplotlib. Here's where Seaborn takes a big leap forward as an improvement over Matplot. It has an attribute, a parameter called hue, which lets you specify another feature. So for instance, I'm going to use title status. Let's go ahead and run it. And what you'll see is that it took the mileages and the years and split it across the various different values that are in title status. Now in title status, we pretty much have a clean vehicle or salvage insurance. And you'll see that it now mapped it. If I had to do this via Matplotlib, it will look something like this. I got the code pasted over here. So you can see, I'm going to see if I can zoom out a little bit so you could try to get both of them at the same time. The charts pretty much look the same, but the amount of code that it took to do it in Matplot was a lot more. Now that's just because this was only two features that I had to explicitly extract from the data set. If that hue value was something more, for instance, if I had done it via the brand, the code in Matplot would explode. Definitely be a lot more than just these 5 lines, because there would be a line for each of the particular brands. Honestly, at that point, I would use a little bit of programming and maybe use a for loop to iterate over a list. Still, I guess what I'm trying to get at is to do it with Matplotlib, it's going to be a little more complicated. Seaborn simplifies that process. So let's explore another chart that can be useful. Again, because charts are all about being able to analyze data. So the next one is the line plot. Again, something you've probably explored in Matplotlib, but let's see how Seaborn takes it up a notch. And let me zoom in again, just because it makes it easier to see. Now, one of the first things I like about Seaborn is that they actually use the word line plot. In Matplot, it's just, in Matplotlib, it's just plot. So just like before, we can specify a data. And let's do x equals, let's do a little something different. Let's do the year versus the price this time. And let's go ahead and run that. So even with the most basic line plot, you will notice that there's something different that Seaborn offers. It offers a shaded region around the line. This is called a confidence interval. What it does is that it looks at the data that surrounds the particular points that form the line and kind of tells you the variance of the data or the possible variance of the data. Again, another great way to be able to analyze your data set. Now I want to do something else here. Let's create a variable called subdata, and let's just extract 3 vehicles from this. So let's do df brand is in, accepts a list, and let's grab the Fords, Nissan, and Dodge. Now the reason I'm only grabbing 3 brands is because there's a lot of brands, and what I'm going to do next is use the hue on the brands. Now if I did that, I would get an enormous numbers of lines, and the legend would actually be pretty huge. Oh, okay. So this happy accident, this is what I was trying to show, what I was alluding to, that if I simply use the brand off of the original data set, which I kept it in the line plot, we would get this huge legend with all these lines, kind of hard to see anything. So let me change the data from being the DF, the original data, to this subset of the data. All right, so a little better. You can compare the 3 vehicle brands next to each other. See how they've increased over the years. See the kind of like the confidence interval around particular points. So you can see here for the Dodge around the 2015, that confidence interval is a lot larger, meaning that we're not very confident with the price that's being depicted by the line. Again, I'll let you explore this more on your own. So let's take a look at another chart, and this one's called a histogram. And we're going to use the same data set. So we're going to say data equals subdata. Now, unlike some of the other features, this one only takes one set of values. Again, because a histogram shows you the distribution of the data in kind of like little bins. So let's see the distribution of the data across the price. And you can see here, this is for all the vehicles. So as we've seen with some of the other charts, we can add the hue parameter and specify the brand. And now we'll get the distribution of the data of the prices by the brands. And in this case, just the 3 brands, because I'm using subdata, not all the data. And again, another great way to compare. You can see the blue is the Ford. So, if I had to say something about 26,000, we had about 100 and maybe 15 cars that would cost that much. And then you can see here the other ones, like the orange is the Dodge. So about 16,000, we had about maybe 90 Dodge cars. Again, it gives you a representation of the data. I like this extra feature. This is called the kernel density estimate. And what it does is that it produces a line, kind of giving you an estimate of where your data distribution can be. Again, another great way to kind of see how your data is working. In this particular case, the prices. One additional parameter I like to add to this one is the element. Now, with all of these, there's other options that you can have. These are just a couple that I like to see because it smooths out the bins into, I don't want to call them curves, but they're not the rectangles anymore. And it's a little easier to see the density estimate along with the histogram. Again, another very valuable tool for seeing the distribution of your data. All right, the next one, which can also help you analyze your data, would be your box plot. And similarly, we're going to specify the data of subdata. And in this one, we're going to do x is equal to price. let's see, should we use price? Actually, let's do the X as the brand and the Y as the price. So, the box plot shows us, let me show you something else. If you recall from earlier videos, and I'll do it on subdata. Actually, let me do it on subdata. I'll focus on the Ford one. Oops. What did I typo? Nice. All right, so what the box plot does is it takes some of this information that comes from the describe, such as the min, the max, these quartiles, and translates it to a graph. Now, again, this can show you a little bit of that density of where your data exists. Again, these are those quartiles. This is the min, and this isn't the max, but I will tell you anything that's above this, you can consider as outliers. So that's one of the things I like to use boxplot for, is to be able to find those anomalies in your data set. So everything above this line, I would consider an outlier, and it might be something that you want to exclude from your analysis or from your machine learning application training. Kind of going along with other things that we can plot from pandas. If you recall, there was something called core, which offers the correlation between features. Now, because there's only 3 columns that are numeric, you could probably just do this and look at it real easy to spot what are your strong correlations. And let me show you what Seaborn offers to visualize this correlation. So it offers something called a heat map. And what it does is that it color codes the correlations between -1 and 1, where the darker colors are a strong negative correlation and the lighter colors are a strong positive correlation. So let's take a look at this one. This one looks pretty dark. So this is year by mileage. Because it's dark, it's a negative correlation. And let's see if that is true. Yeah, year and mileage has a negative almost 0.6. I would say that's a relatively strong correlation there. Let's take a look at this orange one here, which would be price and year. And what we're seeing there is that first, that it's a positive correlation, and then it's not necessarily strong. So if you look at your color chart here, yeah, it lands about at the 0.4. Again, a great way to visualize the information. To give you a better impact on this, let me load up another data set real quick, the miles per gallon, and then show you how that heat map would work here. And let's do the heat map of DF core of this new data set. Oh, I did a copy and paste. Got to change it. Let's load it up again. All right, so this particular data set has a lot more features. So you can see here we got cylinders, displacement, horsepower, a lot more colors. You see a strong pocket down here of negative correlations, a couple of positive ones up here, and a couple of like midway positives. Again, a great tool for when you have a lot of features instead of looking at the core by itself, which will look like this. All right. So let's get back to our presentation and review what we've done in this particular video. So Seaborn is another visualization tool that's built on top of Mathplot that simplifies the process of looking at the data that's in your data set. We saw that it offers some great tools and some great additional parameters to enhance your your visualization without a lot of extra code. I definitely encourage you to look into Seaborn more. This was just a very short overview over some of the things that it can offer to hopefully inspire you to research it more. Enjoy.